Hello, this is a brief overview of degrees and radians. So what are degrees and radians? They're units for measuring angles and can be modeled through circles. Alright, starting with degrees. Degrees can be modeled by dividing the circumference, or essentially the perimeter of a circle, into 360 parts, with each part being equal. So essentially these parts are different equal arc lengths. So I'll draw an example. Here we have our arc length. So the resulting angle from these equal arc lengths, is referred to as 1 degree. 1 degree. Alright, then as for notation, we typically just write that as a small circular symbol on top of the value, or by writing DEG. Moving on to radians. Radians are the relationship between arc length and the radius, where we have the arc length divided by the radius to get our radians. As a reminder, an arc is a segment of the circumference. So as you can see here, we have our arc. Now we know that the circumference of a circle, the formula for it, is 2 pi r, with r being the radius and pi being an irrational number roughly equivalent to 3.14. So our radian value corresponds to the central angle, which is the angle formed by this arc. Central angle. Now with all this given information, we can determine that there are 2 pi radians in a circle, because we know that to find the circumference, we substitute our r value, which is 1. We take this arc length of 2 pi and divide it by our radius of 1, giving us 2 pi. Alright, so for notation, I'm going to take the example of pi over 6, and this will be simply written as RAD. Now, moving on to converting radians to degrees, we're going to start by, so we're given that we have pi over 4 radians, and we'll start by multiplying it by 360 degrees divided by 2 pi radians. This can also be written as 180 degrees divided by pi radians, but let's just stick to what we've written over here. So what our objective is here is to essentially divide out the radians, so we're left with degrees. So to do that, we're going to divide out the pi radians, divide out the pi radians in the denominator here, and we're left with 360 degrees divided by 2 times 1 over 4, which gets us to 180 degrees divided by 4, and gives us our final answer of 45 degrees. Now, from converting to degrees to radians, we can start by our value. We are given our value of 45 degrees, and this time we're going to use our pi radians divided by 180 degrees. Again, our objective here is to divide out the degrees, so we're left with radians. So to do that, we're going to simply divide this out, and we are given 4 as our value here. So we have pi radians divided by 4, or simply pi over 4 radians. Okay, now let's get started on this practice problem. Convert 240 degrees to radians. Pause the video if you need to. Okay, so we're given our 240 degrees. We're going to multiply that by pi radians divided by 180 degrees, because our objective is to divide out the degrees. And based on this, we can see our common factor and work on that through there. So our common factor is going to be 60. So here we're left with 4, and here we're left with 3. So our final answer is 4 pi over 3 radians. All right, now practice problem 2. Convert 11 pi over 6 radians to degrees. Pause the video if you need to. Okay, so we're given our 11 pi over 6 radians. We're going to multiply that by our 180 degrees divided by pi radians. Again, our objective is to divide out the radians. So we do that. Our pi's can be divided, and then our 6 and 18 can also be, 180 can be divided to where we have 30 degrees and 1 degree in the denominator, and that gets us to a total of 330 degrees, and that's our final answer. Alright, that is it for this video. Happy studying, and make sure to subscribe.